integral 0 to pi by 2 x by sin x plus cos x into dx is equal to pi by 2 root 2 log root 2 plus 1. Most important essay question. Very important sum for 7 marks. So to solve this problem, first we take that this total problem is equals to I. Given problem is equals to I. That is I is equals to integral 0 to pi by 2 x by sin x plus cos x into dx. And taking that this is equals to equation 1. Say equation 1. And in the given problem, we substitute that x is equal to pi by 2 minus 6. Now in this problem, we take that the value of x is equals to pi by 2 minus 6. Here this is the formula. Integral 0 to a f of x dx is equals to integral 0 to a f of a minus 6 dx. First, to solve this problem, first we have to apply this formula to the given problem. So that is equals to, in place of x we take that pi by 2 minus 6 by sin pi by 2 minus 6 plus cos pi by 2 minus 6 into dx. And this is equals to integral 0 to pi by 2 minus x by sin pi by 2 minus x is equals to cos x, and cos pi by 2 minus x is equal to sin x into dx. So equation 2. Now adding equations 1 and 2. Same procedure of the last videos. So almost we solve all the problems of the essay questions in this manner. Therefore 1 plus 2 implies first equation plus second equation, that is I plus I is equals to integral 0 to pi by 2. This value. First equation value x by sin x plus cos x into dx plus integral 0 to pi by 2. Second equation value means this value pi by 2 minus x by cos x plus sin x into dx. So this is equals to I plus I. 2I is equals to, so here we have the same limits values to the integration. So taking the single integration, and also denominator also have the same value, that is sin x plus cos x is LCM. Now adding the numerator values, that is x plus this value pi by 2 minus 6 into dx. Now here x and x gets cancelled, which implies the value of 2I is equals to, here pi by 2 is the constant, so taking the constant before the integration, that is pi by 2 integral 0 to pi by 2. Now what is the remaining value here? X is cancelled and we take the constant out of the integration. So the remaining value is here only 1. That is 1 by sin x plus cos x into dx. Now the question becomes here pi by 2 into integral 0 to pi by 2 1 by sin x plus cos x. Now what is the working rule to solve this problem here? So we take that sin x is equals to 2t by 1 plus t square, and cos x is equals to 1 minus t square by 1 plus t square, and dx is equals to 2 dt by 1 plus t square. Now we have to substitute all these values in the above problem to solve this one. And what is t value? Tan x by 2. Now changing the limits values here. Lower limit is equals to, what is lower limit value? X is equal to 0. The problem is in terms of x, so we take that this value as x value, x is equal to 0. Now what is t value? T is equal to tan x by 2. Now substituting that x is equal to 0 here, then tan 0 by 2 is equal to 0. And upper limit is equals to, what is the upper limit value? Pi by 2. That is, now what is t value? Tan x by 2. That is tan pi by 2 pi 2, means this is tan pi by 4, and tan pi by 4 is equals to 1. Substituting these values, therefore the value of 2I is equals to integral 0 to pi by 2. What are the limits values here? 0 to 1. Limits are changed as 0 to 1 into 1 by sin x value 2t by 1 plus t square, and cos x value 1 minus t square by 1 plus t square, and dx value 2 dt by 1 plus t square. And this is equals to 2I is equals to, 2 is the constant, so taking the constant before the integration, integral 0 to 1. Now 1 plus t square, 1 plus t square, same term, so taking the LCM, 2t plus 1 minus t square by 1 plus t square into dt by 1 plus t square. Now here 1 plus t square gets cancelled and also 2 into gets cancelled, which implies I is equals to integral 0 to 1 by 2t plus 1 minus t square. Now taking the values in the order, that is minus t square plus 2t plus 1 into dt. Now how to solve this problem? Now clearly this is a type 1 problem of the integration. Now how to solve the type 1 problems in integration? So taking t square quotient common from the entire term of the denominator first. So first here we have the t square term. Now taking t square quotient common, that is integral 0 to 1. First we take the t square coefficient common. What is t square coefficient here? Minus of t square minus 2t minus 1 into dt. And this is equals to integral 0 to 1 by minus of t square minus 2t. So here in place of minus 1 we take that 1 minus 2. What is 1 minus 2? 1 minus 2 is nothing but minus 1. And this is equals to integral 0 to 1 by minus of t square minus 2t plus 1 is equals to t minus 1 whole square. T minus 1 whole square minus 2 into dt. Now multiplying these two values by minus here, then what we get? Integral 0 to 1 by 2 minus t minus 1 whole square into dt. In the next step, I multiply these two values by minus here, and this is equals to integral 0 to 1 by 2 means in place of 2 we take that root 2 whole square. Root 2 whole square minus t minus 1 whole square into dt. Now this is in the form of integral 1 by a square minus x square dx. And what is the formula for 1 by a square minus x square? 1 by 2a log of a plus x by a minus x. Now applying this formula to find the integration of this term. So we apply this formula here. So this is equals to 1 by 2a means 1 by 2 into a value root 2. 1 by 2a log of a plus x root 2 plus t minus 1 by a minus x root 2 minus of t minus 1. Within the limits are 0 to 1. So this is equals to 1 by 2 root 2 into log of root 2 plus t minus 1 by root 2 minus t plus 1, where the limits are 0 to 1. 1 by 2 root 2 into, now applying the limits values. First we have to apply the upper limit in the entire answer, that is root 2 plus 1 minus 1 by root 2 minus 1 plus 1 minus log of root 2 plus 0 minus 1 by root 2 minus 0 plus 1. And this is equals to 1 by 2 root 2. Here plus 1 minus 1 gets cancelled. Log of root 2 by 2 minus log of this is root 2 minus 1 by root 2 plus 1. So this is equals to 1 by 2 root 2 log 1. Now plus log root 2 plus 1 by root 2 minus 1. And we interchange these two values, then this minus becomes plus. What is the value of log of 1 by x? Log of 1 by x is equals to log of x inverse. Minus of minus becomes plus. And therefore the value of I is equals to 1 by 2 root 2 into 0 plus log of, taking the rationalization, root 2 plus 1 by root 2 minus 1 into root 2 plus 1 by root 2 plus 1. This is equals to 1 by 2 root 2 log of root 2 plus 1 into root 2 plus 1. Root 2 plus 1 whole square by this is a plus b into a minus b, 2 minus 1. So 1 by root 2 log of root 2 plus 1 whole square. And this is equals to, therefore I is equals to 1 by 2 root 2 into 2 log of root 2 plus 1. Now these two terms are cancelled. Therefore the value of I is equals to 1 by root 2 log root 2 plus 1. So I is nothing but the given problem. Integral 0 to pi by 2 x by sin x plus cos x into dx is equals to 1 by root 2 log root 2 plus 1. Most important 7 marks problem.